Hi everybody, Chris AMS, I hope you're well. Welcome to another video. Behind us we've got an Astra K in. It's about 6 years old. Customer's complaint is that the engine light's on and the vehicle is in limp mode, so it has reduced power. Brief history on it: the customer has informed us that it's been to the main dealer. They've had a look at it and suggested a couple of components that could be causing the fault, and their process is to replace a bit. If that doesn't fix it, then we'll replace the other bit, and then if that doesn't fix it, we'll replace another bit. And he was getting estimates of like a couple of £1,000 potentially to rectify the issue. So he wanted a second opinion, hence he's here with us, and we're going to see if we can get to the bottom of it for him. So follow along and let's see if we can get to the bottom of it. Don't forget, like and subscribe, that really helps. So we're sat in the vehicle and we're going to start it up. We've been out for a test drive in it already, and we can confirm that the vehicle is in limp mode. So let's just start it up. Park assist off. So let's have a look and see what we got. So there we have, engine power is reduced, and also we have our engine management light on. So for those of you who've seen our videos before, thank you very much for watching, it really appreciated. We've confirmed the customer's complaint, and now we're going to carry out a full code scan of the vehicle to see what the management system is suggesting is wrong with the vehicle. So we're using our Snap-on Zeus today in order to carry out the code scan on the vehicle. We're in our engine management system. Let's go into codes and see what we've got. So, engine coolant flow control valve actuator control circuit, engine coolant flow control valve actuator control circuit low voltage, and lost communication with engine coolant flow control valve position sensor. So all leading to an issue with the coolant flow control valve. So going into the live data system, there isn't unfortunately much in here that's given us any help in regards to our coolant valve fault. There doesn't appear to be much in the way of data referring to that component. So we're going to have a look at the component itself and see if we can see why it's bringing up these fault codes. So we're under the bonnet of our Astra. This has two coolant flow control valves fitted to it. One's in place of the thermostat that allows coolant to pass out to the radiator. As opposed to now being a wax thermostat, it has an electronic motor and a sensor in its place. And there's another one on the back of the water pump that is controls flow past the water pump. These are designed to allow the engine to warm up quicker and more precisely control the coolant temperature of the engine, or the engine temperature, to make it run as efficiently as possible. Although when these parts fail, they're going to be quite expensive to rectify. So let's see what information we can find, and see if we can look up or start planning out our test procedure. So the two valves that I mentioned, the first one is down here. Zoom in a bit, move that out of the way, you see that there. So you can see the pipe coming off to the top radiator hose. So they've done away with it being a mechanical wax stat and put an electronic motor and sensor in its place, which is nice. And the second one is down here. You can just see it behind, or part of it behind the alternator, which is a little bit more difficult to get to. I think the expression they're going to use with this one is "bear it up God's arse," because that is going to be fun. If that's the bit that we need to change, that's going to be quite interesting to get to. So let's have a look and see if we can find some technical data and then see if we can carry out some tests on them and see which one is the problem. So using our technical data system, we currently use E3 Technical, which we find very helpful and very useful. We have the coolant pump listed. So we've got power and ground into the coolant pump, and then we've got a sensor running pins 3, 4 and 5 to the sensor. We also have the bypass valve, that's there, and again that runs pin 1 and 2 for a motor, and 3, 4 and 5 for a position sensor in it. So we are going to break out our test gear and we're going to see what we've got coming in and out of that. Now remember the fault code was to do with the sensor side of it, so we're going to primarily be interested in the sensor side of the circuit to see whether we're getting the correct readings or not. So having used our technical data system, we have put ourselves together a bit of a test plan. We've pulled the pin outputs for both the thermostat valve and the coolant pump, and what we are expecting to see off the 5 wires that come off of each of those components. And we're going to work through these and we're going to record the results, and we're going to see if we get any discrepancies, and we can decide then whether we've got a component fault or whether we've got a wiring fault kind of thing. So let's get into it. Let's start with the thermostat valve. We'll check that out first and run through it. So we're carrying these tests out with just the ignition on currently, and I am first off plugged in a pin number 1 of the thermostat valve, which should be a supply voltage for the motor, and as you can see there we've got 6.5 volts, 6.6 volts, which is odd. Okay, so I'm not happy with that yet. If we move on to pin 2, which is the other side of the motor, we're back in again. Again, we've got 6.58 volts. Yeah, 6.5 volts. So again, that seems a bit weird. I think we need to investigate that further. I think we'll be breaking out the oscilloscope in a minute just to see we can get a better, more in-depth look at what that's doing. We move over to pin 3, which is our sensor supply voltage. We've got 5 volts. Now this is obviously as well connected, so it's a loaded circuit, so we're happy that that 5 volts there is a good reference voltage for the sensor. Pin 4, we've gone into, we are getting 3.6 volts on our sensor signal, which looks okay. And we're going to go pin 5, which is our ground wire for the sensor, and we've got 60 millivolts, which is sod all, which is showing that we've got a good ground. So I think what we're going to do, before we go any more into testing other components yet, we're going to confirm what we think is going on with this. So we're going to break out the oscilloscope and we're going to plug that in, and we're going to get a better look at the readings that we're getting off of this control valve. So we broke out our oscilloscope. We're using a snap-on scope, 4-channel scope. We've back probed into the back of the valve in there, and we're going to show you some bits and pieces of what's going on with that. So firstly, let's have a look at this. So as you can see there in a bit, these are the 2 sides, or the pins 1 and 2 that go to our motor. And as you can see, we're not getting 6.5 volts. We are actually topping out at battery voltage on either one. And what you're getting with the multimeter, unfortunately, is a mean average, because it can't record quick enough. You're seeing the average of that voltage and not a true reading. So what is that doing, and why is that doing that? So the motor in our thermostat valve is fully electronic. On other types of motor, throttle butterflies and stuff like that, for example, what you would have is a power supply that pushes the motor one way, and then it's sprung, there's a spring in there, and then you turn the voltage off, snaps it back to its closed position. What these do is they use the voltage and it pushes it one way or the other. So the voltage will push it one way, up one wire, so you get more voltage or more frequency on one side than the other, and it pushes it to a certain position. And then when you want to shut the valve, you need to put power into the other side, so pin 2 for example, and then it pushes the valve back to a different position. So if we was to warm this up and watch the thermostat valve open, we would see at some point it would push it over and then close it and control it, and that gives it a little bit more fine-tune adjustment in order to to control where that valve sits. So like see from there, you can't use a multimeter to properly identify whether that control motor or the control signals for that motor are there correctly. So hence the oscilloscope. So now let's have a look at our sensor signal and see what we've got on our sensor wire. So we are now looking at our sensor signal wire. Let me just pause that there. Now remember, using our multimeter we saw 3.5 volts on that wire, and again this is very similar to what we was talking about with the motor voltage readings that we were getting with the multimeter, that it's just simply not quick enough to read what's going on. Now this, what you're seeing here is over a 5 millisecond time base, so that entire screen that we're looking at, that's 5 milliseconds worth of data. Now this is what we call a CENT sensor, which is single edge nibble transmission. Gotta love a nibble. And it is running a 5 volt sweep, so between 0 and 5 volts there, and each one of these is a piece of information. Okay, so this here is giving us in a digital format the position of the sensor. So as that changes, this will change. These are showing ones and zeros, so it's a digital signal. And this works differently from a standard analog signal that you would see, where as the position of the component moves, you would see it move for anywhere between 0 and 5 volts, but in a line kind of thing. So in order to test these properly, again, you have to break out the oscilloscope and get in and test correctly. Now, we haven't warmed this up yet, so we've not seen any differential in the way these signal packets are listed. But so far, everything looks okay on our thermostat valve. So let's move on to our coolant pump, and we'll carry out the same tests on the coolant pump and see if we've got any discrepancy that we can see in that respect. So we have plumbed into our coolant pump valve, and our scent signal, which is in red, is showing low voltage. The 5 volt reference for that sensor is our yellow line up here, so our signal sweep or digital signal should be reaching up around here kind of thing, and we're low on voltage. We're reaching about 3.2 volts. So we know we've got good ground, we know we've got a good 5 volt in, but we're low on that. So our conclusion is there is a fault with that sensor, which is then sending erroneous data back to the engine computer, and that's what's causing our engine management light to be on. So our rectification for this issue is going to be to replace the coolant pump. So we've got our new component from Vauxhall. Here's the coolant pump portion. Here's some rad hoses and stuff. And this is the electronic valve that we were testing. And all it does is it moves that flap in there and basically shuts the coolant pump off. So it doesn't allow the coolant pump to circulate water around the engine and therefore warms the engine up quicker. Now, that's about 500 or 600 quid's worth of bit there, I think, all for that bit that's failed. So, and you can see there, that thing there, that's where the alternator sits over. So, alternator, belts and stuff have got to come off in order to change that. So, let's get on and change this out, and then make sure we've fixed it. So, Phil has replaced the water pump on the vehicle along with that electronic control valve, and you've carried out a test, code cleared it and carried out a test drive on the vehicle, and we're happy to announce that all the fault codes are cleared on the system and the customer's now got full power back. So we'll show you on the dashboard. We've got no faults there anymore. You can see that there's barely any fuel in it, which is a little bit of a bugbear because we want to be able to test drive the vehicle and prove that the fault is fixed. So it's always nice to have some fuel in it in order for us to carry out those tests, kind of thing. But yeah, the customer's fault is cleared. They've got full power back. We've diagnosed it right first time. Unfortunately, the dealer were guessing a little bit as to the problem, and they were going to play a little bit of part starts with it and throw bits at it in order to rectify the problem. But yeah, so a methodical approach has saved this customer a lot of money. So we're happy that we fixed our problem. Occasionally I like to strip down some of the components that we've taken off just to see if we can see a cause as to why the fault has occurred in the first place. So we're going to strip this water pump down, or water pump assembly down, and see if we can see a fault as to why we was getting a faulty sent signal. So we've got the cover off. There's the mechanical water pump component, just a standard water pump that comes out of the housing here. And off the front, we've pulled the circuit board or the plug that we was testing off the front. Now, in the front of there, we can see moisture. So there's engine coolant has managed to leak into the control circuitry of this valve. And all this does is move a flap in there that opens and closes and prevents coolant being circulated by the water pump around the engine. The idea being is it warms the engine up quicker, brings it up to an efficient temperature so its emissions are better and it runs more efficiently in that respect. But we have, it's difficult to probably see, we have engine coolant in this circuit board on the end here, and that's what's caused our faulty sent signal. So it's nice to be able to strip these components down and work out why they failed. Unfortunately, because of that, we've had to replace all of this, which is quite an expensive component. Unfortunately, I don't think there's any way around that, but at least we know the cause as to why this component has now failed. I hope you enjoyed this video. Please like and subscribe. Leave us a comment, let us know what you think, and check out some of our other social media. We've got YouTube, we've got Facebook and stuff, and hope to see you in the next video. Take care. Remember, test, don't guess.